Here we're clearing the syringe of any bubbles. We're going to wipe down the syringe to make sure it's not that oily prior to placing it in its box. Going to make sure that it's properly labeled. We're going to close up the box to make sure that the sample is not prone to any photo degradation. It's okay to take the bubbles out when you first sample. But if you come back and that syringe has a large bubble, please do not remove it. It is most likely part of the sample. What we're doing now is, although you don't need this for sampling, you can use it. It is a moisture sensor that is used to monitor the moisture coming out of the valve prior to sampling. In this case, what we're doing is we're removing the bushing adapter with the tubing on it after we close the drain valve. And again, you're going to see some oil come out, and you'll understand why we use the pan to collect that oil. So what we're going to do now is install the connector for the moisture sensor to attach onto the transformer drain valve. This connector already had Teflon tape on it, but if you did not have it, then it would be a good time to put it on. Threading the connector into the drain valve and securing it with a wrench. This is the old Domino Porta sampler, which has been replaced by the Domino USS. It's very similar in construction, but much easier to use. Here we're attaching the manifold, and then it's attached to the instrument, which shows us the parts per million. The new ones actually provide a graph so that as you're removing the oil from the transformer, you can actually see the water content go down and plateau. Once that happens, you know you have a clean valve. In this case, we're attaching tubing to the manifold, and we're going to flush oil through the tubing, and the sensor is installed into that manifold. We're going to let the tubing into the waste bucket to collect the oil that's coming out of the drain valve. In most cases, you should do this activity first, as it will give you a good idea about how much oil to remove from the transformer drain valve. In doing that, you know that you've removed as much moisture as you can from that valve using this instrument. Although difficult to see here, you could see that it does say the parts per million. Now the parts per million is not going to change too much here because the transformer has already been flushed. But on occasion, when you first start, you'll see a dramatic decrease from the moisture in the valve as we get to the bulk insulation. And that means that you are pushing the moisture from the valve out into waste and then have a good sample. You can see that it has not moved much. It was only about 29 ppm to start with, and now it's down around 26, so there's not much moisture left in that drain valve. In certain cases, you will find that it takes a lot more oil to flush out certain valves than other valves. Things like stainless steel valves do not hold on to moisture as long as things like cast iron valves, etc. So the moisture sensor becomes a good tool to use when determining how much oil to actually flush out of the drain valve.